because I appointed myself as an organizing committee, so I took liberty, first of all, to organize the agenda in the way I organized. The truth is that I don't know, apart from Eugene's lecture, I don't really know the contents of the lectures. I wanted it to be a surprise for myself. And I also took a liberty to present 2 lectures today. Okay? The second one is essentially a continuation of the first, but I decided to put it in the end because I hope, though I don't know what we are going to talk about, it will be a kind of a summary of what we're going to discuss today. And of course, we have a hidden plan, which we'll probably discuss later over dinner. So the first lecture will be Principia Informatica. The second lecture will be Memory and Meaning by Joha. The third lecture will be The Freedom of Will on a Specific Example by Mikhail. Then General Theory of Order by Eugene. The Flood. That's
Theory of Order and Cosmos.
And Cosmos. Of Order and Cosmos, sorry, by Eugene. And The Flood, that's how I translated the presentation that Leo prepared. And the last lecture is Intelligence version 2 by myself. I'm a little bit nervous, so it will take a time to...
Just time to remind everyone to...
Yeah, it's the first time, you know. You get used to
in
it.
quiet.
By the age of 70, you get used to it.
Yeah, but we have a psychologist here, so that's like... Okay. Many of you heard about my ideas in what I call Principia Informatica. I believe Joha even read one of the versions. Eugene certainly read one of the versions, and as a word, 2 versions. As a word of introduction, I started to think about all of it about 20 years ago. I found my first notes from 1994. And the reason I started to think about it, and I'll explain what is it all about certainly, is because I was, and I'm still puzzled by the usage of word entropia. Now, entropia is a word which, as we learned in physics, and we'll hear much more about it in Eugene's lecture, of course, is a kind of something that we associate with chaos, disorder. And we were taught that, according to the second law of thermodynamics,
Chaos everything. In '94 he started working with Eugene and with me. So it's all related to...
By the way, sorry, I wanted to say one thing about the agenda. I suggest we don't ask questions in the middle. That's why we have paper and pen here. Everyone who wants to ask the questions, just writes them down and then asks in the end.
How about remarks in the middle?
Sorry?
How about
just
you can throw eggs or something like that, but no questions. And by the way, one of the lecturers is gonna do it the other way around. He's going to ask questions from the audience. That's as much as that much I know. So anyway, I started to think about. I was puzzled by the usage of the word entropy. So entropy, according to the second law of thermodynamics, is something which grows in every physical process, in closed systems and with all the limitations, but I'm not going to go into details now. So, and the idea is that whatever you do, you increase the entropy, you increase the chaos. There were even a lot of scientific or science fiction books about the what they call the thermal death of the universe, meaning that at the end of the day, everything will become sand and warm, and no structures will remain, and everything will disappear. Everything will disappear. Now, the second usage of the word entropy is used in the information theory of Shannon. Now, it's also used as a measure of...
Theory of what?
Shannon information theory. That's information theory very roughly, without going to mathematics. No, there's no single formula in my presentation, of course. Is something about transmission of signals. He worked in Bell Labs and developed a very, very practical thing for radio signals, transmission of signals from one point to another point. And he also used the word entropy for the measure of chaos, but it's a chaos in something completely else, stunningly different. Essentially, it's a kind of mathematical abstraction, because there is no real chaos in electronic signals, or if there is, in the information transmission. see the amount of information that you have here and the amount of information that you have here, and in the middle something happens in your channel, and then you have kind of like entropy is growing. So again, he was using the same word, this was a genius, and it's so dramatically and drastically different from the usage of the word entropy in the physical world of physical processes. You heat something, you break something, you build something. So that's point number one, which was very, very puzzling and still is very, very puzzling for me. And point number two is that, yeah, I've heard about the thermal death and about the increase of chaos and anything that happens about us. Now, but if you look around, what you see in the outside world is completely opposite. Is completely opposite, which Eugene calls, I believe, reverse second law of thermodynamics, which is completely opposite. We see a lot of self-organizing matter. Galaxies are creating stars. Cosmos is developing. The chaos is evidently, I'm not talking about life. Think about like life on Earth, human life, new children, civilizations, human societies that we build. The amount of chaos is certainly decreasing and not increasing. Okay, so it was like kind of very, very puzzling for me. So I started to think about it and decided to call it Principia Informatica. Not very modest, you know, not very modest association, but still. So agenda of my lecture now, it was a short introduction, is the failure of Newtonian world picture, an attempt to define what's information in physical systems. Then we will talk about time and cause and effect relationships, about meaning of time, possibility of prediction of future, freedom of will, and then I'm trying to define what I call 3 Zaidenberg laws of Informatica. Now, to talk about any kind of a world picture, we need to do certain assumptions about methodology, because, you know, if we have like a kind of religious approach, a theological approach, or solipsistical or materialistical approach, we have to define what is that we are talking about. So of course, and it's very, very evident what I'm gonna, and everyone knows it, but I need to say it just to start from something. So methodology is rooted in the ideas of Plato, meaning that there is a separation, very, very clear separation between the world of ideas and the physical world, the world of ideas and the physical world. Now, there are many approaches or theories. How is it that we can at all understand the physical world? But typically what we say, it's a kind of a comparison between a theory and the physical world. Empirical verification of certain abstract ideas that, at least in theory, are somehow developed in some of our brains without direct connection to the physical world. And I'm not going to go into this right now, but that's just my basic assumption. So in order to understand the universe, we need to have 2 systems. One, the system of ideas, and the system, because there's no meaning in understanding of universe if one system doesn't exist. So if you only live in the physical world, okay, so there's nothing to compare to. And if you only live in the world of ideas, then okay, again, nothing to compare to, so it's not very interesting. Now, what are the main building blocks of our understanding of the outside world? Is, of course, the Newtonian mechanics and gravity, thermodynamics, relativity, special and general, and quantum mechanics. That's what our world, our understanding of the outside world is built on. And by the way, all of it has been proven many, many times over. The fact that airplane can fly and the car can drive and the computer works is all based on these ideas, and there's no question, experimentally proven for many, many times over. There is no question of the validity of these ideas from the point of view of methodology that I have defined before. Now, but what about the most important questions? We have a huge amount of knowledge that is developing all the time, and still we don't have answers of on the 4 most basic and most interesting, at least for me, questions. So first of all, where did the cosmos start? Eugene will talk about it. How life appeared on Earth, how the brain works, and meaning our brain. I can put it another way. Is there any difference between us and animals? Of course there is. So what's this difference? Okay. So life, humans, as opposed to the animals world, and of course, even more interesting question, how in the world human organizations develop and build and operate. So the first and second laws of thermodynamics, as I told, certainly don't give answers the other way around. We see it's all developing, becoming more and more complex, more and more sophisticated, and less chaotic. Systems are self-organizing. Now, I have a lot of examples here, but I want to go into details. Now I'm starting to come to what I think are my ideas, and I want to analyze two examples here, just to give an introduction to the definitions of the next slide. Now let's think about seemingly most simple physical process. I'm standing on top of a hill, I take a stone, and I throw it down the hill. Okay? Now, on the face of it, according to the most basic laws of physics, Newtonian physics, you can exactly predict what will happen with a stone. It will hit the first stone on the hill, jump to another stone, then jump again, and at the end of the process, it will settle down somewhere. Now, is it that simple? Do you know in real life what will happen? Of course you will say no, because it depends on the wind and on the temperature and 1,000 parameters that you don't know in real life. But even more so, or you can't even measure them in the real life, but even more so, it depends on the configuration of the stones on the slope. So if there are stones that are lying in this way, it will jump like that, and the other way it will jump like that, okay? So notice something. What's more important here? The laws of physics or the configuration of the stones? Think about software and hardware. Where's the software and where's the hardware? The real answer to the question where the stones land is in the configuration of the stones, the speed of the wind, the temperature, and so on and so forth. If you wish, the Newtonian laws, according to which you can exactly calculate how the stone will jump on every jump, is only, I would call it, operating system, like you have in your phone or in your computer. What dictates the outcome of this very, very simple event is information encoded in the stones on the slope of the mountain. And the physical world, and I'm jumping ahead, is only a side effect of this information. Now, think about more complex example, which is DNA. More or less, I presume that everyone knows more or less how DNA works. Now, does it really matter that DNA is, God Almighty decided to implement DNA on amino acids? Should it be silicon structures or, I don't know, any other chemical material? It won't matter at all. What matters is the code, the information, whatever is encoded in DNA. DNA, which in the end of the day dictates who any animal, how it will look like, including ourselves, and the computational process that works there is encoded in so-called codons, genes, and so on and so forth. Very, very complex and very sophisticated mathematical informational structure. And the fact that it was implemented on certain hydrocarbon molecules seems to be not central to this thing. Again, information dictates the outcome, dictates the shape of our world, the software, not the hardware. And the specific hardware probably is not that important. The other, I'll give another example. Actually, this example is from late Professor Leibovich. Just one phrase: bus company. If you have a lot of buses, it doesn't mean you have a transportation system, right? Okay, so the transportation system is something else. It's the information, the spirit. Now it will be a little bit boring, but unfortunately I have to give some shape, to try to give some shape to whatever I'm trying to present. is the so there will be a lot of definitions, Some of them are more abstract, some of them are less, but we'll try. So first of all, what's a program? What's a program? You can use a word algorithm, which is also used as a word program, but it's a general way of solution. You have a problem and you have a general way. What does it mean, general? It can work on a different sets of data. In professional language, it's called instantiation. Per instance, instantiation. Now, look, think a little bit about it. A program includes all the possible outcomes. If you wish, all the possible worlds, all the future, and also all the past. Think about a simple computer program now, not about these things. In the program, before you start running it, the output can be this and this and that. But so all the possible outcomes, all the possible futures, exactly in Kabbalah, by the way, as in the fourth world of Kabbalah, are included, encoded in the program. And once you instantiate it, meaning you apply it on a specific set of data, only then you know the specific output, what will happen with your outside world. Now, a program cannot run on any possible data. Every program, like in, again, simple example in computers, there are some programs that will work only on numbers or even like natural numbers, and the other program will only work on partial, but it doesn't matter. So the all possible sets of data on which a program can work is called abstract datum. It's the world, all possible inputs. Now, operating system is an interface between programs, data, abstract datum essentially, and the hardware, the physical world. You can see it in a computer. Operating system is something that when you push a button on your keyboard or today on your screen, knows to tell the hardware what to do and knows to transfer this information to a specific program which is running on the computer. It's exactly the same thing here. Now, information system is a program together with abstract datum and operating system. Now think again about my example of a rolling stone and of DNA. Now I'll skip the next point. It's a little bit. Now the last point is, what does it mean to run or execute a program? To run a program or to execute a program means to take a specific set of data out of all possible datum and to instantiate the program from here to here, from here to here, from here to here. And now you have an output. And now the stone landed. So it created the physical world. The program creates the physical world, not the other way around. Information system exists out of this world, out of the physical world. If you wish, it hibernates. It was there before the Big Bang and will stay there after the world will disappear. Now the future is encoded there, but per se there are no time. There is no time in the information system because there are no cause-effect relationships. The cause-effect relationships, they only are born when specific set of data is applied. The instantiation starts.
Is this an axiom?
No, that's my definition. That's okay.
No, information system exists out of time and space.
No, I'm trying to explain again. What I'm trying to do again, I'm defining what's an information system. I mean, you can use any other word, but I thought a lot about terminology. Okay, terminology is important. So I'm trying to use the words which on one hand are known, but still give me enough flexibility to define the concept. So in the sense that I define operation system, it's a definition. Okay? It's something that exists outside of the physical world, hibernates there. Now, what's a physical system then? A physical system is something from our world, meaning it's a set of physical objects which can be clearly separated and distinguished from the abstract or spiritual part of it. So information system resides inside it, but it's not part of it.
Say it again.
Information system resides in the like the software sits in the hardware. Without hardware, software is dead. There's even no time there because there are no cause-effect relationships. It only comes alive when it starts running on a specific set of hardware. It's exactly like body and soul.
The question, what does the wind do when it doesn't blow? Okay, what do you mean it hibernates?
Again,
Where?
it's no God.
You don't know.
What I'm trying to say, why I think it's useful. We'll see it a little bit later. Why I think this way of thinking is useful, because I'm trying to emphasize that the physical world is only a side effect of what I call information system, and the hardware implementation doesn't matter, like with DNA or with the stone. So we have a set of laws, as I said, okay? Programs, operating systems. Newton laws are typical operating system. No, exactly like Microsoft Windows. Yeah.
What question about come but
They're just mechanisms.
Exactly.
But you say the physical world is just, I would say, it's a private case. Like economists used to
Correct.
say, the real world, the private case of the theory.
I call it even worse. I call it a side effect. Now, side effect in computers. Okay, I'll explain it. Okay, I wanted to skip it, but I'll explain. Side effect in computers is something which is left in the memory once the computer, that program stops running. So it changes the memory. So it's a part. What remains exactly with the stone. There are all laws of physics and everything, which the stone was rolling, then it stopped somewhere. What remained is the position of the stone. So it's a side effect. Now, another thing which Eugene will have to comment about it, the living system, or a living matter, is a physical system that is able to reproduce an old or to create a new information system. Okay? Like, very simple example, animals. They are able to reproduce. What I'm gonna claim later is that we humans are different from the animals by the fact that we can produce completely new information systems. Principally new information systems. We are here to create intelligence 2.0. Next version. Now, one observation, which is, again, I would like Eugene to comment on it, is...
Sorry, I didn't
Yep.
understand the phrase. You are saying, for example, animals that create new information systems when the definition of information system is something that exists out of time and space. So...
No, information system, what I said, information system is all together, okay? It's together with the hardware. The software part of it, that should have emphasized. The software part of it creates, before it starts running, it creates out of time and space. It's out of time and space, okay? Now, another remark, now let's think about systems like galaxies, okay?
Don't get lost.
Sorry?
Don't get lost trying to answer questions.
Yeah, because guys, that's right. Write the questions. That's right. I don't. Yeah, please. I'll try to answer the question. Okay. So Now look. Now one more comment. Look at the system like a galaxy. Okay. In a certain way, it behaves like a living system. New stars are born. Some kind of new information is created there. Okay, or at least replicated. Something. Now I try to think about it, but it's of course Eugene who will give a better answer. My feeling is that the more global stretches of time and space we are looking at, the more systems are becoming like living systems. Okay, if we look at something like really, really big, like a galaxy or a universe or a nebula or the whole universe, then the behavior is somewhat similar to the behavior of living systems that we know, like animals or humans. Now, types of systems. Now I'm trying, after trying to give this definition, which is of course very, very difficult, I'm trying at least, which is somewhat simpler, to define the types of information systems. I define here 5 types of information systems. First is what I call entropy-driven. Very, very simple. This like with a stone. In the end of the day, entropy increases. The second is self-organizing non-living systems, like galaxies, like probably galaxies. I call them info-driven, info-driven. Now, the third level is of complexity is life-driven systems. That is like animals. Then, of course, humans, which I call knowledge-driven, meaning that they can produce completely new systems. And the fifth is social-driven. That is like human organizations which can produce even more complex structures. Now, you know what? I'll probably skip that, and we'll go to time and cause and effect relationships. Now, so what's time? Time is a linear sequence of cause and effect relationships. Okay, something starts here, goes there. Something starts here, goes there. Now, as we said, per se, in the information system, it doesn't exist because it covers all the possible outcomes. And only on the specific run, on specific instantiation, all this cause and effect if-thens are straightened into one linear form. So time only in principle sits in the information system. When it starts running, then it becomes, the time appears. Also something which probably Eugene put. Now let's think about possibility of is it possible to predict future? And what does it mean? And by the way, the past, it's exactly the same. Is it possible to understand the past? There's no difference. Now, first of all, in order to predict the future, we have to clearly distinguish between software and hardware, where the information system is and where the physical world is. Because, then we have to do what we call decoding. That's try to understand. I'll give you an extreme example just to illustrate what's it all about. Imagine a guy coming from another universe, galaxy or whatever, and someone who sees a computer for the first time in his life. Okay? And computer is doing very, very simple thing. Printing salary slips for Misha's bank. Okay? Okay. So there are two approaches. To understand how the hell the system works. One approach is like we take it apart, take a scope, and try to measure electric signals on the chips. I think it will be that's called neurophysiology. Okay, I think it will be very, very difficult to understand how the system works, because you need to understand where the hardware is, where the software is, and at the end of the day, you need to understand the taxation laws of Russian Federation. I mean, like just to understand what the hell is going on there. Okay, which is a very simple process, right? Now, another approach is psychologist approach. They do something like this. They take a keyboard and like push a few buttons and see what is the reaction. Okay, and try to connect between no, sorry, okay, no comments.
I want to protest. Yeah. Please.
Don't need to go to
Yeah.
external world. So, you know, ask Misha if he understands how it works.
Yeah, so what I'm saying, in order to understand the complex information system, first of all, you have to distinguish, to understand where is the software and where is the hardware. And then you have to understand all the layers, where is the operating system, and where is the program. And then you can start to do what we call abstract interpretation. Now, abstract interpretation, again, I'm always using computer terminology. When you have a program, you can run it without data. So you can somewhat limit the amount of outcomes. Not all the possible outcomes, but somehow like make it smaller. Now, what happened? Essentially, you predicted future a little bit, not too big. Like you limited the amount of possible outcomes. You limited the amount of possible outcomes of your problem. That's called abstract interpretation. Now, of course, we are doing it all the day in the Newtonian physics, like with the stone. But again, it's only in theoretical world. In laboratory, it jumps exactly where you want. You need to have all the picture of the information system. Now, I say that the purpose of us, the humans, in this world is to decode as much information as possible. That's a main mitzvah, the commandment in Hebrew. God created us in order to be able to understand the information system or the God, doesn't matter, okay? We have to decode as much information as possible. And in the end of the day, that means that the amount of entropy must be reduced and not increased. Now, paradoxically enough, one of the possible, we can also do something that will destroy ourselves, and the atomic bomb is only one example. Unbelievable sophistication and amount of information was decoded and understood in order to create a tool that can ultimately destroy us altogether. Freedom of will. The more decoding is done, the more future is predicted. And the more future is known, the more choice and freedom of will exists, and the less deterministic the world becomes. In Talmud it says, everything is determined, but authority is granted.
What?
Authority, the rashut, the choice, authority. I translated as authority. I thought a lot, like it's not a standard translation. Yes, we're authorized to do something. Before life was here, the world was absolutely deterministic. Think about the moon. Nothing happens there before the humans came and left it footprints. And the meaning of life is to decode more information to obtain more freedom. We are the ultimate anti-entropic tool. And probably will create the new version. Intelligence 2.0, we'll talk about it in my last lecture. And just to summarize, 3 laws of Informatica. The information system exists out of time and space. But they need a body. So they reside and are executed on physical systems. Time and cause and effect relationships are side effects of many, many runs of information systems on various data sets.